I have 5 envelopes in front of me. That means that it's time for another mailbag. First one up is this pretty big one. It's actually almost the whole width of the field of view of my camera, and it says that it is a auto bulb times 1. I did order some auto bulbs, but they were a lot smaller than this. Get through this packaging here. Nice. Let's take a look at this. So these are just supposed to be some 12-volt LEDs in a metal housing and a little bit of wire. This came from one of my eBay auctions, but I don't know if you can tell, but this box is quite damaged. Don't think it fared so well in shipping. Yeah. See that bend? So yeah, that's a bit disappointing, but straighten it up and see if it'll work. And the other one, some adhesive backing. Don't need that. Actually, it's probably not a good idea to use the adhesive backing. You probably need to heat sink this a little bit. But if you were thinking of using this kind of LED just on your car, well, I don't think that's a good idea, and here's why. Let me just open these tabs here. I don't know if that one will open, that's okay. This is a totally unprotected, unheat sinked, it does have an aluminum backing, LED. But the aluminum backing is so thin, this would never be a heat sink. The wires here are so tiny as well, look at that. They're like 30 gauge maybe. I'm going to pull this sleeving off if I can. I don't think it'll go. Let's see if we can strip a bit more of this. This is just really crummy plastic, vinyl. Actually, see if I could slice a bit of the insulation off. The insulation's not too bad. It has fibers on the inside. But this really tiny wire. This was $1 on eBay for both of these. I think they actually sell them for more. It's just that I got them at an auction. Strip these wires back. I don't even think this is a proper... I just broke the wire right off. Yeah, I don't know. I don't think I would buy these for automotive use if I were you guys. Gonna strip a good length of wire, and you know what? We can actually test how hot they get. There's one piece. I wonder if the wire actually works as a fusible link of sorts. Okay, let me get set up so we can read the temperature of this LED, and I'll bring you back. So here I have my multimeter, and I have a thermocouple. Here I have my power supply. I've tried to lower the light level for my videos so you can see a little bit better. I have been getting a recommendation to put some red tape over this, but I have to find that tape first. Here's the LED, and here's the wires. I'm just going to plug these into these little quick connects I have. These quick connects are great, by the way. These wires aren't so great. Okay, so those are the wires in. Try to keep everything in shot. Now my thermocouple, I'm going to tape it with Kapton tape onto the back side of this LED here. And I don't really care if we destroy the LED. We need to know if these should be able to run. Now, if I turn this on, thermocouple showing 19 degrees Celsius, which is what my house temperature is right now. So basically, it should be able to be hotter than that, simply for the fact that you could actually run these in summer, right? So 20 degrees C right now on the substrate, probably because I was handling it a little bit. And now I need to set my voltage. I'm going to set up to, let's go 13.5. Actually, my car runs at 14.2 with the alternator, so let's do 14.2. And let's watch this. Now the LED is faced away from you guys because I don't want to dazzle the camera. But here it goes. And it is on. It's blue? I mean, it's a little white. Oh, I'm on current limit here. Let's turn this off. Let's see. Aha, current's limited to 200 milliamps. Yeah, on your car you won't have a current limit, so let's move that up. We'll let it go all the way up to 3 amps. I don't think it'll be that much though. No, you have 500, about 500 milliamps here. And it is really blue. It is like nearly, it's very blue. Whoops. And our thermocouple fell off here. Let me put that back on. There we go. 34 degrees C. And climbing. 35 is still on. The current is fluctuating a lot here, but it's about half an amp. So each of these things, right, if you figure 14.27 volts, half an amp, so it's about half that, 7 watts a piece. 45 degrees C. It's getting a little hot now. 44. 45. I wonder how hot it's going to get. Nearly 50 now. And you'll see the current here will climb slowly. It's all over the place. Are these wires getting hot? No, not really. $55. Starting to get pretty hot. I'm going to let this go for a little bit and see how far it goes. So it seems to be climbing a lot slower now. We're at 75 degrees Celsius. That is pretty hot. It's not too hot to touch, but it's too hot to leave your hands on it. It's pretty hot. So I would say this would not be a good idea to use on a car with an unregulated power supply. Oh, so it's 76 now. It might actually climb up into the 80s, but 77. Maybe we'll let it go a little bit longer and see what happens. And 80 degrees Celsius. I think we're going to end it there. This is very hot, although I think it might actually go up a little bit more. I think we've had enough torturing this little device. But yeah, basically too hot. You should probably not run this on your car just as is. You need some sort of switching power supply. Probably run this at 12 volts and it'd be fine. So actually, let's see if we can set this to 12 volts. So bring this down to 12 on the dot. There we go, it's on at 12 volts. And look, the temperature is dropping. It's actually shedding the temperature faster than it can heat up at this point. Yeah, that's cooler, that's for sure. Only 144 milliamps, that would be way better running at 12 volts. And I think that's what they intend it to run at, but again, if you're just going to connect this to your car, your alternator will overvolt this thing. So that's pretty neat, but good for doing house projects, not particularly good for using in your car. Let's move on to the next one. Next one is this one, and this is extremely light and tiny. Looks like there's one piece right there. I'm not quite sure what's in here, but it says LED patch. I don't really know what LED patch means. Holy crap. Okay, let's take a closer look at this thing. So what this is a wedge bulb, usually used in automotive instrumentation, but really there's nothing to this thing. This is another one of the auctions. I think I paid 11 cents for this, something like that. Wanted to check it out, and these are supposed to slip inside of a base to light up gauge clusters or whatever. It's got 3 LEDs on it. It's got 4 resistors. So 2 of them on one side are 2150, so 215 ohms, and on the other side it's 2210, so 221 ohms. Not quite sure why that is, but let me set up for us to be able to light this, and we'll light this and we'll see what's next. So I have my power supply here set to the 14.2 because again this is an automotive type bulb, and I've got my giant comparatively crocodile clips, and so we're going to actually plug this up and then turn it on. I'm not sure if there's going to be a polarity difference left or right, but I guess we're about to find out. And there we go, let's turn this on. Oh, there, it's lit. And actually it's not too bright, which means it's not like crazily overvolted. I got to be careful not to short these clips because don't have my current limit. Only 50 milliamps on this is a very sane current. 50 milliamps by 3 LEDs. That's like less than 20 each milliamps, so that's perfectly fine. But yeah, nothing much to see here, unfortunately. Just a nice little bulb. I might use this for indicator LEDs or something like that. I was just curious to see how it was made and what it would look like. And so I bid on it, and I got it for really cheap. I think it was 10 or 11 cents Canadian, which is pretty much nothing. Alright, let's open another one. Next one up is this heavy and rattly one, and description says screw, so it makes sense it would be heavy if screws are made of metal. I have been trying to order hardware so that when I want to do mechanical builds, like put the stuff together, I'll have parts. Let's take a closer look at what this is. So these two are exactly what I was talking about. They're just hardware to have on hand for when I need it. The thing is, the local hardware stores in Canada, these things could be quite expensive. They could be like 5, 6, 7 cents each, sometimes even up to 15 cents, depending on where you go. And these are washers, M4 and M5, and they're to complement my M3s I already had. So I have 3, 4, and 5. And here are some M4 screws. that I have in stock, and then I have the washers to go with them. And here's some M5 screws that I have in stock and the washers to go with those. So yeah, nothing special. They're stainless. The M4s cost me $2 Canadian, and the M5s cost me $2.50 Canadian. And that's pretty good for 100 stainless washers. Like I said, they can be expensive if you need to buy them locally, and I want to have them on hand for when I do mechanical builds. Like I do have a few planned that I'm going to need, so it's good to have these on hand. And if you don't have some screws, some nuts, some washers on hand of a few different sizes, you probably should. And if you get them from China, yeah, it'll take, whatever, a month or two or more to come in, but you'll have them if you order them far enough in advance, and that's what I do. Okay, but nothing special to see here. We can move on to the next ones. I feel a trend coming on here. This one says nuts. So is it M4, M5 nuts to go with the washers and bolts? Not sure. Nope, not at all, in fact. Let's take a closer look at these. So what these are again are, well, T-slot nuts. And I'm saying again because if you're familiar with my mailbag videos, you'll know that I actually got a bunch of these not too long ago. How come I ordered 2 sets? I don't know. Actually, I can't even find record of myself ordering 2 sets, but anyways, here they are. So there's 50 M5 sized T-slot nuts and 50 M4 sized T-slot nuts, and I think I have enough T-slot nuts to last me a while. Now, for those of you not familiar with T-slot nuts, this is aluminum T-slot or extrusion, commonly used for 3D printers and things like that. And what's nice about these nuts is that they actually fit inside of these extrusions. These are 20-20 extrusions, meaning they're 20 mils in this direction by 20 millimeters in the up and down direction. And so these fit inside here. Another nice part about these T-slot nuts is that they'll actually sit down, they'll go in like this, sideways, and then when you tighten them up, they'll spin sideways. See that? So they'll go in this way, so like this, and then once you put them in and you tighten them, they'll spin like that, and they'll grab hold of the extrusion. And so, yeah, not much to say here. I paid $3.20 for each set. I don't know why I have so many sets. I think what happened was I ordered some so long ago that they weren't coming, and I decided to reorder, I guess. And yeah, I got both kind of really close to each other in time-wise. But nothing special to see here. We can move on to the next package. Lucky last one today is pretty big. It's pretty thick. It's good sized, and on here it says relays. There's only one set of relays that I've ordered, that I remember ordering. So I should know what these are. Oh, that's broken. That's very broken. Oh, that's a shame. Let's take a closer look at these. So what these are a pair of AC relays. Now, pretty much all relays have a rating for DC and AC over the switch contacts, but these guys have a rating for AC over the control contact. So the actual solenoid is an AC solenoid. The only thing is these are a bit scarier than I thought. So they have the bases here with all the connectors broken out onto screws, like these little where you pinch the little wire inside that terminal there. And they do have a rail mounting system. You pull this back, you pull this back and push it onto the rail. So that's all well and good. However, these broke. So right here you can see the plastic's broken. And that's a little crappy because that's so you don't go and touch these contacts. Especially this one here, because I believe it's this one, which is actually the 110 volt or 120 volt coil socket. This one's broken on this side too, same side, which is quite a shame. So that's good. Now these here, here's the scary bit. It says designed in Japan, made in China down here. So I don't think these things carry any kind of certification, so you can't really use them in your house wiring. And how they work, I know there's a lot of pins here, but you just have to think of these two are the coil contacts, so this will actually the control side, and it's actually wired up to a little red LED up there. So this is the control side, and these here are all individual circuits. So this one here is the common, so common, 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 and they switch between these two. So like let's say this one would switch here, probably easier with a pointer. This contact here would be switched between these two. One of these is normally open, the other one is normally closed. And same thing, this one would be these two, this one would be these two, this one would be these two. And you can see that right here. See this pin here? This pin here continues through the case, has this contact here, this pin here, this contact here. There's a little air gap between the this middle contact here, and this middle contact is touching this one, and it's going over to a wire and coming over to this one. So you see this and this, that's normally closed circuit, and on this side is normally open between these two. So how this works is you would have your load on here, and you want the load you want to switch on, or sorry, the power coming in on here. The load you want to switch on would be here, going to the load. When this here gets power, when the coil gets power, this little arm here, this little contact is going to switch over to this one and connect these two together, meaning this will be closed, your load will turn on, and then when you disconnect power from these two here, then it'll switch back, and now these two will be connected again. So if you, let's say you wanted a load to always be on and turn it off at certain times, you would connect it between here and here. It'd be always on, and then you send a command signal to turn it off, to switch the contact over here. I would love to give this a shot, but I have no good way to plug in an AC load without getting my fingers zapped. And especially these, I don't trust these as far as I can throw them. I don't trust these as far as anybody can throw them. I would need to be completely isolated from these in order to try them. So I think that'll be a hard pass at this time. But again, I do have a plan on making a test device that should be safe, that I can test things from a distance and of course video it in case things go wrong. But until that time, yeah, I'll pass. And these just go simply in here like this, and then all these terminals are broken out to here. So your coil contacts look like 13 and 14. So you just look on here to see if you can find a 13, 14. There's 14 right here, and there's 13 right here. So this would be your control side, and everything else would be the rest of your circuit. Let's see, 9, 10, 11, 12 are the commons. Let's see where they put the 9, 10, 11, 12. There's 9, 10, 11, 12 here. So that makes sense. You have your control here, 9, 10, 11, 12, or 9, 10, 11, 12 this way. Is that 9? Yeah, that's 9. This would be your normally your commons. I don't know what 4 is. So this one's nonsensical because all the rest here are the normally open and normally closed ones. This would be the normally closed on this side, except for number 4, which is put over here. Yeah, not very well thought out, but I guess they needed space for the M4 mounting hole here. I'm not too impressed with these, but they were cheap. I think they were about $2 each, and so it was worth a gamble. But I'm not sure if I want to actually try them without a safe way of isolating myself completely from these things. Also, the project I had in mind for these things, they're going to be way too big, so that's going to be a no for that. So, I don't know, maybe we'll toy around with them in a video, but I don't think I'll put these to any serious use, so yeah. And this wild assortment of, I guess mostly hardware in this case, makes up today's mailbag. Thanks for watching.